Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P050B, indicates a problem within the cold start ignition timing control system of the 2008 to 2012 Honda Accord. Specifically, it signifies that the system isn't performing as intended. The ignition timing control system plays a crucial role in optimizing engine performance, especially during cold starts when the engine is first started. Faults in this system can lead to poor engine starting, higher emissions, and diminished overall performance. This code is associated with components such as the crankshaft position (CKP) sensor, the engine coolant temperature (ECT) sensor, and other critical engine management sensors. Before beginning troubleshooting, it's important to record any freeze data and snapshots that may help inform the diagnostic process. The steps outlined in the following slides will guide you in identifying the root cause of the issue and restoring functionality to the ignition timing control system. The cold start ignition timing control system helps regulate the ignition timing of the engine during the cold start phase. This system relies on various critical components, including the CKP sensor, which is located near the crankshaft and helps determine the engine's position and speed. The ECT sensor monitors the coolant temperature, which is vital for adjusting the ignition timing accordingly. Other components involved may include the throttle body and manifold absolute pressure (MAF) sensor. Any dysfunction in these parts can lead to the P050B code, impacting the vehicle's ability to manage ignition timing during the initial startup phase. These components are primarily located within the engine bay, making them accessible for inspection and repairs. Understanding the roles and location of these components is essential in executing effective troubleshooting. The potential causes for the DTC P050B are varied and can originate from different sources. One of the first things to consider is the presence of any other pending or confirmed diagnostic trouble codes, DTCs, aside from P050B. These may indicate additional underlying issues. A blocked intake air duct can restrict airflow, disrupting the engine's air-fuel mixture and affecting ignition timing. Additionally, damage to the air cleaner housing can lead to similar airflow issues. A dirty air cleaner element can also hamper the engine's intake process, necessitating either a replacement or cleaning to ensure proper function. Furthermore, misconfigured ignition timing may arise from issues with the CKP sensor or other related components, impacting cold start performance. Each of these elements plays a vital role in maintaining engine efficiency, particularly during cold startups. Common symptoms associated with DTC P050B primarily revolve around engine performance during cold starts. A poor cold engine start indicates that the ignition timing may be off, preventing the engine from starting smoothly. Rough idling can also manifest if the engine does eventually start. This occurs when the ignition timing does not adequately adjust for the cooler engine temperature. Additionally, higher emissions could be a symptom, as incorrect ignition timing can lead to incomplete combustion and increased pollutants being expelled into the exhaust. These symptoms not only degrade the driving experience, but can also lead to potential long-term damage if left unaddressed. Identifying these symptoms early is crucial for preserving engine health and performance. To initiate the troubleshooting process for DTC P050B, begin by turning the ignition switch to the on second position. This action powers the vehicle's electrical systems without starting the engine, allowing diagnostics to be performed. Once the ignition is on, the next step is to check for any pending or confirmed DTCs using the Honda Diagnostic System, HDS. A pending DTC indicates an issue that might be present intermittently, whereas a confirmed DTC signifies a persistent fault. The presence of any additional DTCs aside from P050B is critical. If other codes are indicated, they must be addressed first, as they may point to related issues affecting the ignition timing system. If no other DTCs are present, proceed to the next troubleshooting step. The second troubleshooting step focuses on the intake air duct, an essential component for proper engine operation. Inspect the duct for any blockages that could be obstructing airflow to the engine. This blockage can disrupt the air-fuel mixture during ignition, particularly affecting performance during cold starts. Additionally, examine the installation of the intake air duct. If it is incorrectly installed or damaged, it can create leaks or inadequate airflow. Ensure that all connections are secure, as loose fittings can also cause performance issues. If the intake air duct is found to be either blocked or improperly installed, it should be reconnected or repaired to allow for optimal air intake before proceeding to the next step in the troubleshooting process. Following the inspection of the intake air duct, the next critical step is to check the air cleaner housing for any signs of damage. The air cleaner housing is essential for ensuring that only clean air enters the engine, protecting it from contaminants. Damage to this component can significantly impact airflow and the overall performance of the ignition timing control system. This step involves visual inspection to look for cracks, holes, or loose fittings that could compromise the air intake efficiency. If damage is detected, the air cleaner housing must be replaced to restore proper function. This is a crucial part of the troubleshooting, as an undamaged housing is vital for maintaining optimal engine performance. After verifying the integrity of the air cleaner housing, the next step is to inspect the air cleaner element itself. This component is responsible for filtering incoming air and preventing dirt and debris from entering the engine. A dirty or clogged air cleaner element can restrict airflow, leading to suboptimal engine performance and potentially causing the ignition timing to malfunction during cold starts. During this inspection, remove any visible dirt or debris from the element and assess its condition. If the air cleaner element is excessively dirty, it should be replaced to ensure that clean air is delivered to the engine. Proper maintenance of the air cleaner is essential for ongoing performance, especially in environments with high dust or pollutant levels. The next step in troubleshooting involves letting the engine cool down until the reading from ECT sensor 1 reaches 122 degrees Fahrenheit, 50 degrees Celsius, or less. The engine coolant temperature sensor plays a crucial role in providing accurate temperature readings to the engine control module, which adjusts the ignition timing accordingly. This step is essential because improper coolant temperatures can result in inaccurate sensor readings, leading to erroneous performance metrics. Allowing the engine to cool down ensures that the diagnostics are conducted under proper temperature conditions, representing a typical cold start scenario. Once the ECT value is confirmed to be at the specified level, you can move on to clearing the DTCs and evaluating the system's performance under these controlled conditions. Once the engine has cooled to the appropriate temperature, the next step is to clear the DTC using the Honda Diagnostic System, HDS. This step resets the system, effectively removing stored fault codes and preparing for a functionality check. After clearing the codes, start the engine and allow it to idle for at least 10 seconds. This idling period allows the vehicle's onboard systems, including the ignition timing control system, to reinitialize and assess whether the previous issues persist. Monitoring the system at this stage is crucial, as it provides insights into whether the trouble code reappears. A successful idle without issues would imply that the system is functioning correctly, warranting further inspection of connections if the code does return. In this troubleshooting step, you will monitor the onboard diagnostics OBD status for DTC P050B through the HDS. This monitoring is vital, as it tells you whether the system is functioning correctly or if it has failed a diagnostic test. If the HDS indicates a failed status, this means that the ignition timing control system has not met operational parameters. In this case, you will need to proceed to further diagnostics to pinpoint the issue. On the other hand, if the status indicates passed, the system is functioning correctly at that moment, although intermittent failures might still exist. It's also essential to check for poor connections or loose terminals at critical points such as the CKP sensor, throttle body, MAF sensor, and various temperature sensors to ensure all components are communicating effectively. This step is crucial for confirming system health. After monitoring the OBD status, the next step involves inspecting the ignition timing of the engine. Proper ignition timing is critical for optimal engine performance, especially during cold starts. Using the HDS, assess whether the ignition timing is within the specified range for proper function. If the ignition timing is found to be accurate, the diagnostic process continues on to subsequent steps. However, if the timing is incorrect, further investigation is necessary to ascertain the source of the malfunction. Misaligned ignition timing can lead to various performance issues, including difficult starting and reduced efficiency. So this step is paramount for diagnosing the root cause of DTC P050B. In the event that the ignition timing is not within the acceptable range, the next step is to check the crankshaft position, CKP sensor, and the CKP pulse plate for any damage. The CKP sensor provides crucial data to the engine management system about the crankshaft's position and speed, which directly influences ignition timing. Inspect the CKP sensor and pulse plate visually for any signs of physical damage, such as cracks or corrosion. If damage is found, replacing these components becomes necessary to restore proper sensor function. It's important to ensure that the sensor is correctly aligned when replacing, as any misalignment can lead to ongoing performance issues. Successful repair of this part is essential for rectifying the cold start ignition timing problem represented by DTC P050B. The next troubleshooting step is to conduct the Electronic Throttle Control System (ETCS) test using the HDS. This test assesses the functionality of the throttle actuator control valve, which is responsible for managing air intake throttle positions based on engine demands. A properly functioning throttle actuator is essential for ensuring the correct air-fuel mixture, especially under varying loads. If the ETCS test indicates that the throttle actuator is performing normally, you can proceed to the next step in the troubleshooting process. However, if it highlights any issues, replacing the throttle body becomes necessary to correct the throttle operation. This inspection is vital because any mismatch in throttle response can directly affect ignition timing during cold starts, contributing to the code P050B symptoms. After completing the necessary repairs based on the previous steps, it's crucial to validate the effectiveness of the fixes. Begin by starting the engine and allowing it to idle. While idling, monitor the system closely for any reappearance of DTC codes, specifically P050B. The absence of the fault code upon restarting would confirm that the issue has been resolved. If the code returns, further investigation into other components in the ignition timing control system may be necessary. This final verification step is essential to ensure that the previous issues have been adequately addressed and the vehicle is functioning properly. Moreover, any improvements in engine performance during cold starts serve as additional indicators of successful repairs. Preventive maintenance is vital in ensuring the longevity and proper performance of the ignition timing control system and the overall engine. One essential aspect is the regular inspection of the air cleaner element. Keeping it clean prevents airflow restrictions that can lead to ignition timing issues. Additionally, sporadically checking the various sensors, such as the CKP and ECT sensors, can help catch any potential malfunction early on. This proactive approach can significantly reduce the risk of future DTC P050B occurrences. Scheduling preventive maintenance as part of regular vehicle care can also enhance overall performance, fuel economy, and ensure that components are functioning optimally. Effective maintenance practices lead to reduced wear and tear on engine components. In summary, DTC P050B points to a performance problem in the cold start ignition timing control system of the 2008 to 2012 Honda Accord. The troubleshooting process should start with a careful examination of relevant sensors and air intake components, which are essential for optimizing ignition timing during cold starts. Significant attention should be given to components such as the CKP sensor, air cleaner, and intake duct. Each of these elements plays a pivotal role in ensuring proper engine function. Furthermore, regular maintenance practices, including inspecting air filters and sensors, can prevent issues before they manifest into serious problems. By following these troubleshooting steps, you can effectively address and resolve DTC P050B, leading to improved performance and reliability of your vehicle. Please like and subscribe to the channel. See you next time.